Okay, here's part 2, the rest of the review. Now, this is already set up for us, and we're asked to solve for t. So we're going to take all our steps, and we're going to work backwards. We have 100, 1.02, 2 to the t equals to 500,000. We're solving for t in the exponent here, so we want to get rid of as much as we can. We're going to get rid of the 100 first. Divide both sides by 100. 1.02 to the 2 to the t is equal to 5000, because we got rid of some of that. And now the way we get rid of this, we're going to do a log to both sides. This time I'm going to use, you can use a common log. If not, you can use the log base 1.02. So let's use log base 1.02. So if I log 1.02 to the 2t power equals to log 1.02, 5000. You're going to be left with just 2t is equal to log 1.02, 5000. And we divide both sides by 2, but I want to make sure you do this on the calculator first. 2t is equal to log 5000 divided by log 1.02. Then with that decimal answer, divide that by 2. Okay. And so once you divide this by 2, you're good to go. You'll get some answer on your calculator. Okay, find the logarithm in this problem. One thing you want to be hopefully good at now is that this is going to cancel out. Let's do it the long way. Log base 2 to the 1/3 power. Logs always bring down exponents to the front. 1/3 log base 2 of 2. And if you remember, logs offer exponents. 2 to what exponent is 2? 2 to what exponent is 2? Isn't that just 2 to the 1? So this cancels out to just be 1. So we're left with 1/3. Or just, that cancels out. Okay, next one, solve the given equation. You can see that we have a base 6, 4x minus 5 is equal to 40. And there's no way for me to make 6 and 40 have the same base. So what I'm going to do is I'm just going to use logs. Log base 6, 6 to the 4x minus 5 equals to log base 6 of 40. We're going to see that 4x minus 5 is equal to log base 6 of 40. Remember, this is a calculator work. That will give you some decimal number. So log of 40 divided by log of 6, change the base. Once you do that, you're going to add 5 to both sides and then divide everyone by 4. So this, if I don't do it now, fine. It's going to be log base 6 of 40 plus 5, all divided by 4. And that's what you put in your calculator. But I think to write that in your calculator might be a little confusing. So I always say do this first, then you can plus 5 and divide by 4. Super easy from the calculator. Okay, next problem is 2 to the x equals to 41. So I'm trying to solve for my exponent here. There's no way for me to get from 2 to m2 times 2 times 2 to get to 41. So we're going to do log base 2. 2 to the x equals to log base 2 of 41. And that's going to bring down that exponent. X is equal to log base 2 of 41. You could also solve that this is an exponential form. We could do circle of logs. Log base 2 of 41 is equal to x. Super fast, and you can type that in your calculator by saying log of 41 divided by log of 2. Okay, number 22, convert 6 to the t power equals to 1640 to a logarithmic form. And then they want us to solve for t. Okay, let's change it. So to write this in log form is log base 6 of 1640 equals to t, right? That's our identity. And we can rewrite this as log of 1640 divided by log of 6. And that calculator answer will solve that for us. And the answer you're going to put there. Okay, e to the 5x equals to 27. I don't know e to what 5x would be to become 27. It's not a whole number, it's going to be a decimal. So I'm going to natural log both sides because that's how we get rid of the e. And then we have 5x equals to 27. Sorry, natural log 27. We're going to divide both sides by 5. So remember I tell you to do that on the calculator first, then divide it by 5. So x is equal to natural log 27 over 5. But of course, remember you're going to divide that you're going to do natural log of 27 first before you divide by 5. And that's just some decimal answer that goes here. Okay, we're back to solving logs. As you can see, there's two logs here. We have to somehow combine those logs first before we can get rid of the logs. So log of x plus log of x plus 4 means I'm actually multiplying. And then I'm going to take the base 10. Oh, in this case, I'm sorry, it's not base 10, it's base 3. I should have wrote that. 3 to both sides. X plus 4 is equal to 3 to the 6th power, which is some number. 3 to the 6th power is 729, I'm sorry. And then x squared plus 4x. I want to move the 729 over, so minus 729 is equal to 0. And to solve this, we'll have to use, you can have the factor, but I don't know if that's factorable, so if you want to use quadratic formula, x equals to negative b plus and minus square root of b squared minus 4ac all over 2a. And that would help solve it for us. Now once you get the answer, you want to double check if they both work or none of them work. Back here, remember, logs can't be negative and they can't be 0. Okay, so our next problem, I see natural log of 3x plus 5 equals to 3. Okay, we're going to e both sides, because that's how we get rid of the natural log. Hopefully we're used to that. 3x plus 5 is equal to e to the 3rd power, which is some decimal number. So on your calculator, you can just type that. Then you're going to minus 5 to both sides. And then you're going to divide 3 next to get rid of that guy. So x is equal to e cubed minus 5 over 3. And you should do this on a calculator, then minus 5 and divide by 3. So that'll be very fast for you. Since I have a calculator actually in my left hand, e cubed is 20.08. We're going to minus 5 to that, and then divide that by 3. I'm getting 5.028. Okay, 26. Find the solution of the exponential. E to the 2x plus 1 is equal to 33. How do I get rid of the e? We natural log both sides. Natural log e 2x plus 1 equals to natural log 33. See you later. 2x plus 1 is equal to natural log 33. Now, again, since we have a natural log, I'm going to do that on the calculator first. I'm going to get rid of the 1 and then divide that by 2. So natural log of 33 is 3.49. I'm going to just write what we're going to do. Natural log of 33 minus 1 divided by 2. Because we're going to get rid of the 1 first, then get rid of that 2. We're going to minus 1 divided by 2. You should get something like... Sorry, 1.248. Okay, now this problem here, 10 to the 2x minus 9 is equal to 9 to the 2x minus 10. How would you solve this guy? They have different bases. Let's go and log both sides. If I say log of 10, 2x minus 9 is equal to log of 9, 2x minus 10. What happens to the exponents? They get moved to the front, right? This is 2x minus 9 log 10, which is some decimal number, is equal to 2x minus 10 and then log 9. No, let's keep going. If I multiply this out, this would be 2x log of 10 minus 9 log of 10 equals to 2x log of 9 minus 10 log of 9. These are just numbers, decimal numbers in the calculator, so I'm not worried about them. What I'm worried about though, oh, actually no, this guy, we could get rid of him. That's log base. That's actually just going to become 1. So this goes away. This goes away. I could set that back here. I could set that back here, and we're left with 2x minus 9 is equal to log of 9, sorry, 2x here. 2x log of 9 minus 10 log of 9. Let's move all the x's on one side. So I'm going to move this over. We have 2x minus 2x log of 9 is equal to negative 10 log of 9 plus 9, because I moved this 9 over. We can factor out the 2x's here. 2x. Actually, you know what? I'm just going to just factor out the x. You can keep the 2. It's going to be x left over 2 minus 2 log of 9 equals to negative 10 log of 9 plus 9. Divide that all over. X is equal to negative 10 log of 9 plus 9 over 2 minus 2 log of 9. Okay, and that's using all our skills from logs. And that's just some calculator decimal answer. Okay, last one. Find the time required for the investment of $5,000 to grow to $6,300 at an interest rate of 0.75% per year, compounded quarterly. So this is compounded quarterly, and a quarterly is A is equal to P 1 plus R over N to the NT power, where N is quarterly, so that means 4 times a year. Our R is 7.5% per year, and our principal starting off with $5,000, and we wanted to grow to 6,300. So 6,300 equals 5,000. 1 plus 0.075 over 4 to the 4t power, because we want to figure out how much time it's going to take us to get there. We can get rid of this first. That's 6,300 divided by 5,000. Then we have equals to 1 plus 0.075 over 4t. We want to get rid of this base because we want to bring down the exponent. So I'm going to use a natural log or a common log or a special log here. In this case, I can use a specialty log. The specialty log will be a little bit hard to write, but log base 1 plus 0.075 over 4 of 6,300 over 5,000 is equal to 4t. Now, you're going to type all this in a calculator. How are you going to type this in a calculator? Remember, we have to write this log in our calculator, so it's going to be log on top of 6,300 over 5,000 divided by log of 1 plus 0.075 over 4 is equal to 4t. Now, once you type this into a calculator, divide this by 4, and you end up with the time it takes you in years for us to go from 5,000 to 6,300. Okay, and that's it. This is probably the hardest problem. This and number 27. And we're good.